Hi, this is Kalivani from Chemistry Department, JJ College of Arts and Science. Today we are going to discuss about the anthocyanins. So anthocyanins is nothing but it's belonging to the natural product, especially in natural pigments. So this slide shows about the anthocyanins. So basically anthocyanins is a flower blue. Its color is blue color. It is water soluble flavonoid pigments, especially it's belonging to the category of flavonoid. The color appear as red to blue. According to the based on the pH, it will be changed from red to blue. Occur in all tissues of higher plants, but color not noticeable. Have purple color and are present in some other vegetables like onions, cabbage, potatoes. So which means in red, blue and purple color. So this slide shows about the examples of fruits and vegetables belonging to the anthocyanin pigment. So apple, pomegranate, cherries, blueberries, these are all the examples. So let's introduction about the anthocyanin. Anthocyanins is specifically orange, red, blue colors. In foods, strawberries, berries, which means blueberries, cherries, blackberries, grapes, and some vegetables such as eggplant and avocado. So most of the anthocyanins are water soluble because of form hydrogen bonds with the water due to the presence of multiple hydroxyl groups because it's having the various categories of anthocyanins. So first of all, common anthocyanins isolated from natural resources. So what are the common anthocyanins present in the natural product? So it is anthocyanins in the form of cyanidine, peonidine, pelligrodinin, malvidin, delphidine and petudinin. So these are all belonging to the hydroxyl groups present in the particular carbon. So next move to the chemical structure of anthocyanin. So anthocyanins are subdivided into the sugar-free anthocyanins, which means in the form of allegones, and the anthocyanin glycosides. The basic chemical structure is phenylium cation, which means the chemical name is 2-phenyl benzopyrrolium, which links hydroxyl group or methyl group. It's belonging to the more sugars. So it's having more, basically it's a 3-ring benzene ring. So it's category of A, B, C. So this slides also describe about the structure. So these are all the structure of the anthocyanins belonging to the various flowers. Around 12 anthocyanidins, most common in leaves in cyanidin. So especially the common name is anthocyanidins, but in the presence of leaves it is in the form of cyanidin. The names of compounds generally reflect species from which they were first obtained. Thus, pelagrodin is from pelargonium or geranium. It often exits in pink, scarlet and orange-red flowers. Next, delphidine was named after delphinium and generally mauve or blue flowers have this compound. So these are all names given by the according to the occurring the colors and consist of 3 carbon rings. Already I told you carbon that is a ring A, ring B and ring C. What distinguish anthocyanins from anthocyanins is the presence of sugars, generally at the carbon third position, which means is belonging to the glycosides. So this only we have to distinguish between the various types of anthocyanins. Sugar can include glucose, arabinose, rhamnose and galactose. Now the degree of hydroxylation or methoxylation on the B ring, more methyl oxy it's red, more OH is blue, which means if it is OH is present, that particular vegetables or fruits having the blue in color, it is having the methoxyl group, that particular vegetables or fruits is having the red color. The electron deficiency particularly reactive towards electron lusting reactive oxygen species, simply called ROS. So these are all the general structure of anthocyanins. So here the R1 and R2 it's having the according to the based on the presence of methyloxylation or it's a hydroxyl groups. According to this we have to get the different names. So next one we get the biosynthesis. So here we have to get the two pathway of getting anthocyanins. One is the acetate pathway, another one is ischemic pathway. So first one, the produce in response to light, whether it will be visible or UV. The production results from two synthesis pathways, acetate and ischemic acids. The acetate pathway produces 3-malonyl coenzyme is a more reactive part of this biosynthesis. The ischemic acid pathway produces the phenylalanine is the more active part of this biosynthesis. The two pathways combine to produce the base molecule, the narginin chalcone. So these are all combined to get the basic molecules narginin chalcone, which will make to produce the anthocyanins. So anthocyanin can react with a bisulfate ion to form a colorless 2 bisulfate adduct product. So this helpful to do the in jam, dry fruits and dry vegetables. This concept is adding in this type of food materials. So the above reactions colored cationic when added with the water it will give the uncolored pseudophase form, which means at the position of equilibrium moves to the right, which is colorless. The blue quinodial base, the stable at the pH level is 6 to 7. The red flavulum cation, which means AH place, stable at the pH level is 1 to 2. The colorless carbonyl pseudobase, which means B, stable at the pH level is 4 to 5. The colorless chalcone at stable at the level below 7. It produces the brown products. This is the reaction that most colorless containing anthocyanins can only be used as pH value is greater than 4. Next, move to the stability of anthocyanin. So this is very most important thing. Then only we have to consider the anthocyanin derivatives. Unstable with the pH, temperature, UV light and Fe3 plus and Al3 plus ions. High temperature doing cooking, anthocyanins is decomposed. The most stable position is at low pH, especially in acid medium and low temperature. So these are all these structure getting the different colors. When you have blue color, it's turned to red color. It is getting these reactions. So the colorless and is also getting the when you are treated with the water, it gets the colorless form, both blue and red. So anthocyanin at different pH, the resulting of adding cabbage juice to solution of different pH values. So this is the very good examples of having different pH level is occurring by the anthocyanin. Acidic pH below 7, it is used in the acetic acid. When you are using distilled water, the pH level is 7. When you are using sodium bicarbonate, the pH level is 8 to 9. In ammonia, the pH level is 10 to 11. In pH, it's 11 to 13. So these are all the results of adding cabbage juice to solution of different pH values. It's curving the different colors. So these are the effect of substance on the color of anthocyanins. Why you are getting the different colors, especially a single family of anthocyanins getting different colors because of the presence of hydroxyl group or methoxyl group present in the particular carbon. So for example, pelargonium, cyanidine, delphidine and petidine and malvidine. So all these we have to notice that it's a position of OH and methoxylation is a effect to get the different colors. When you are having OH is high, it's getting bluish color. When you are having methoxyl group is high, it's getting more red color. Structure of anthocyanin. Anthocyanin pigments is composed of aglycone, which means an anthocyanidin esterified to one or more sugar. So anthocyanidin is nothing but in the form of allicone. So anthocyanin with the sugar, we get the different categories. Well, already we know that pelargonium, cyanidine, delphidine, phenodine, petudine and malvidine. These are all having the different name belonging of organ and the R2 having the different molecules in that particular position. For example, in pelargonium, the organ is hydrogen and R2 also a hydrogen. So it is called as the pelagrodin. If it is cyanidin, the R1 is a OH, R2 is a H. In delphidin, R1 is the OH, R2 is the OH. In phenolidin, R1 is the methoxylation and R2 is the hydrogen. In pitinidin, R1 is the methoxylation and R2 is the OH, like that. And malvidine, it is R1 is the methoxylation and R2 is also a methoxylation. So it's belonging to the different elements present in the particular R1 and R2, we get the different categories of anthocyanins. So this table shows that anthocyanins occur in some fruits and vegetables. In apple, it is belonging to the cyanidin. Blackcurrant, cyanidin and delphidin. Both the anthocyanins are present. Blueberry, cyanidin, delphidin, malvidin, petudin and pyridin. This is the most, it's a very good example of pure anthocyanin because it having the all the categories of anthocyanins. Cabbage, especially a red cabbage, is having the cyanidin. Cherry, cyanidin and pheonidin. Grape, this is also having the malvidin, peonidin, delphidin, cyanidin and petudin and pelagrodin. Orange, cyanidin and delphidin is only present. In peach, cyanidin, plum, cyanidin and peonidin, radish, pelagrodin, raspberry, cyanidin, strawberry, pelagrodin and a little cyanidin. So this is the last slide of this session. So natural acid base indicators. The cyanide is also, it is belonging to the category of its indicators, acid base indicators, especially acid base indicators, because of the structure differ in the various compounds like cyanidin, malvidin, the position belonging to the R1 and R2. The structure three phenol groups, which means benzene ring with the conjugated carbon-carbon bonds and varying number of hydroxyl groups, glucose molecules bound to the oxygen atom on the second phenol group. Anthocyanins are found in food high in sugar content, so especially it is found in the sugar content. It is also, it acts as a acid base indicators. Thank you all.